Ladies and gentlemen, welcome back to another live stream. So in this live stream, we're going to be creating a UI library in SDL3 from scratch using SDL, obviously, and Yoga library from Meta, which is used in React Native. So it would give us some Flexbox layout, and we would use it with SDL3 renderer and SDLTTF to render that layout. And we'll see where we go from there. Obviously, it's going to be open source, and anybody is welcome to contribute. In fact, I really would love this to kick off because there's just a huge gap in the ecosystem, and we really need to get together and make something very lightweight and simple, and you just use it to create a little UI, and that's all. So here we go. I have a little protocol that, sorry, not protocol. What is it called? Prototype, right? That I was working on. It's mostly my code. Some of it is a bit generated, not generated, but like assisted through the AI, and that's all. And I got something working like this, right? And that's what we're going to be working on today, but we're going to be doing it from scratch. I'm not going to be starting from my prototype, essentially. So that was just a prototype, right? So live. And there you go. Obviously, I'm not going to shy away from using AI in this stream, so if that's not your cup of tea, feel free to leave, just so I don't waste any of your time. And yeah, that's all. Otherwise, you're welcome here. So pretty much, like if you want to create a UI library, oh sorry, a UI in C++ or whatever, or any low-level like, in fact, anything really. Like your only options, like you don't have that much options. You have Qt and you have Ceph, which is basically embedding the whole Chromium, or you have React and Native or Flutter or whatever. All of these are huge, huge library. Hello, Theo Paris, our admin. Welcome to the live stream. Very, very huge. But on the other hand, you have a lightweight library like MGY, but MGY is not retain mode, it's immediate mode, first of all. And second of all, it's, what can I say? It doesn't have a proper layout system. And also, it's not dependent on anything, which is great for some people, but I would love my UI library to be a bit opinionated and rely a bit on the ecosystem. Like libraries and such. For example, the Yoga library by Meta that it's being used in React Native, that's a perfect dependency because it's very self-contained and it gives you a lot in return, a lot of return on your investment. But yeah, obviously we're going to be using SDL3. We're going to be using only the 2D renderer for now. But maybe later on, if we need, we're going to be using SDL3 GPU. Because to be honest with you, for 2D workloads, unless if you're going to do in some shaders like blurring or whatever, then you don't really need the SDL3 GPU. In fact, it could be slower if you don't implement it properly. But we'll see. Either way, that's that. I think let's get started already. Believe so. The chat on my right. If you guys have any questions or suggestions or whatever, please let me know. Other than that, I think let's get started. Okay, so we're gonna create a new project. And C++ library, not executable. So this is going to be a library that you could basically pull into your executable and you could use it easily. So language standard. Let's go with the latest. Why not? Who cares? Library type, static or shared. Let's go, I guess, maybe with static for now. And for the C++ library, what are we going to call this? I'm going to put it in my D drive, which is like a dev drive on Windows, but yeah. So what are we gonna call this? I guess let's call it Kodotaku UI. Very creative. I would love also instead to call it SDL UI, but I didn't want to actually do that because who knows? Maybe SDL would want to make their own UI library, and it's definitely not going to be in C++. It's probably going to be in C, so I'd rather not do that. So let's just go with Kodotaku UI pretty much. And let's go. So language standard, there you go. Cool. Create. And let's see what we got. All right. Exclude folders. I'm not going to give you a master class on creating like open source libraries, but I'm going to try my best. Neither like creating UI libraries, to be honest with you, but I can get you, you know, somewhere there, at least starting over, right? But anyways, all right, let's see what we got here. So this is what we got. Okay, so let's create, well, let's actually change some few settings first of all. I always like my save actions. Whoops. Obviously, I'm using C-Line. You could use whichever IDE you like or whichever build system, but I'm going to be using C-Line with CMake, modern CMake. Other than that, we're good to go. There's also Xmake, which I really liked, but well, the standard, the industry standard did CMake, so yeah. Okay, so I think, and I also got used to CMake at this point, to be honest with you, but anyways, so that's the save actions. And yeah, let's go to CMake and change a few things there too. So here I'm gonna go with the build/debug. And I'm gonna use the Visual Studio toolchain, which means basically MSVC and the Ninja generator, fine. And yeah. Okay, we could remove this one. And let's just say git init. We're gonna be using git submodules to pull dependencies, I think, or should we? Actually, yeah, we're gonna do that. Fine. And let's make a directory called, let's go with third party, fine. And let's go inside of that third party. And let's say git submodule, add SDL3. So I honestly would love to use this SDL3PP port, like it's basically a C++ wrapper, but as a library, you gotta be a bit, you know, a bit conservative with your choices of libraries, and also the fact that if this guy gave up on this library and then he also got a catch every single time with the library, or should we just try? I mean, we could like just change it at any single point in time, to be honest. Should we give it a try, guys? Should we give it a try? Should we go with SDL3PP? I mean, it would give you out of the blue, like when you get it, it's just gonna give you SDL3 image, mixer, TTF, and everything. Honestly, you know what? Let's give it a try. Let's give it a try. I don't care. Fine. Let's give it a try. I never tried it, but it should be good to go. Okay. We could change it later on if we have a problem. So we're gonna remove this third party folder then. Well, actually, we still need the third party, but you know what? I think we could use fetch contents for that too. Anyways, fine. Let's just see what we have. So we're gonna include fetch content, and then we're gonna fetch content declare is the L3PP external. And apparently it's just, instead of git cloning, he's just grabbing the latest release, I think. Right? Is that the case here? Yeah, 0.11.3. And then fetch content and then target link libraries. And my project here is this Kodotaku UI library. And yeah, other than that, obviously, since we're on Windows and we want the library to pull the dependencies itself, at least for now, we could basically enable all of these. So it would give us the SDL image, it would give us the mixer, the net, and the TTF. Well, we don't need all of those. So for now, at least, I think we're gonna need only the TTF and the image, SDL image. So yeah, we could pull those. And is there anything else other than that? Like, let's see. Yeah, there is this one also. You gotta make sure to say SDL3PP force bundled. Nice. Instead of trying to find them on your system. Already on by default. Oh, okay, so SDL image is already on by default. And SDL TTF, no. Okay, so what we're gonna do, we're gonna basically first of all set this to on. So it would grab the libraries for us. In fact, here we go. We could just like incomment this guy. And we gotta make sure to add the CTF too. And yeah, all right. Now, if we reload this, reload. Okay, so what? Oh crap, why the heck it's using MinGW? That's strange. It's trying to pull the MinGW one, which is interesting. Well, you know what? I guess that's a red flag already. So you know what? Let's just go with let's just go with the default stuff. Fine. Let's just do it ourselves, please. Oh my god. I don't want to be debugging other people's stuff now right now. So fine. Let's remove this stuff. So yeah, let's just use some modules. Let's just use some modules. So that was a little detour right there. Okay, so do we have that? Let's see. And let's go inside of third party and let's say get some module add. Let's just go with SDL and hold on a second. I'm gonna come back in a second. Okay, back. Back. Hello, Neo VCPP. Welcome to this live stream. All right, so we added the get submodule SDL here to the third party. And we're gonna also add SDL TTF. So let's look for SDL TTF. And we're gonna go with skits module add SDL TTF. And we'll also need SDL image. And finally, we're gonna need Yoga library. This is by Meta, which is being used in React Native. We're gonna be using it for our layout. So we're not gonna be remaking the wheel. In fact, I tried like if there was some other libraries that would have made our job easier, I would have done it. But honestly, this is the only library that I've found that is an embeddable layout engine that is self-contained, you know, and very well tested and everything, and easy to actually even include using CMake. So yeah, thanks to Meta. Right, obviously it's open source, it's MIT, so great. Other than that, git submodule add for our layout library. It's basically Flexbox layout. And yeah. And I think these are the libraries that we're going to use for now. For now. Maybe later on. We might add Lua, honestly, at some point. Well, not now. Let's not think about scripting for now. But we might do it at some point. Anyways. All right, so after you do this, what you do? Well, you just simply say add subdirectory third party slash SDL and exclude from all, and then add subdirectory third party slash SDL image, exclude from all, and then add. We could have done a list and then a for loop, but I could never remember CMake syntax. So yeah, you know the pain. Add subdirectory third party slash yoga. Right, yoga. Exclude from all. Well, it's gonna actually say something about free type and stuff. Yeah, we're gonna see about that in a second. So let's try reload, and there's gonna be a little error, but you could easily fix it from SDL TTF for its dependencies like free type and harf buzz and all sorts of things. But we're gonna see about that one. So configure SDL image using vendor zlib. Okay, so this is the kind of problems that you're gonna find when dealing with this. So what you're gonna do, it's actually pretty simple. In fact, it tells you exactly what you gotta do. And what the heck is going on here? Wait a second. In fact, hold on. Can I do this and this? Perfect. Okay, so let's go to our terminal, and we're gonna go inside of that third party. Oops, what the heck is going on here? Okay, so we're gonna go inside of the third party. Well, we're already inside of third party. Let's go inside of SDL image. Let's see what we got here. So, let's go inside of external. And look at that. We have one doloid.sh script for Linux if you're on Linux. And we have a PowerShell script called git modules. You gotta actually run that. Honestly, I'm not sure how we're gonna deal with that when it comes to. Should we actually include those libraries ourselves, in fact, and call it a day? Oh my, look at that crap. SDL image is insane. I mean, we could just support only PNG, to be honest. In fact, like SDL itself, like already just uses PNG, really. I'm not sure if they changed anything in the new SDL image, because I actually haven't used it yet. Right, wait, there you go, SDL image. I mean, we don't really need SDL image for now. You know what? We're gonna deal with that crap later. Fine. But just get modules and let's go. So you just run that PowerShell script and it would basically clone all the external dependencies it needs for you. Same thing with SDLTTF. It also, if you go to external, you're gonna find a script here, PowerShell script, that you gotta use. So that's a lot of dependencies. So SDL image is very heavy, but that's the price you pay if you want to support a lot of image types, not just PNG and BMP. Like SDL2 used to only support BMP, and you had to use SDL image even for PNG, but nowadays SDL itself, like SDL3, does support PNG. So if you don't need GPG and the other ones, then you actually can just remove SDL image. But I'm not sure if I want to do that, like, because like at that point you're gonna, force the users of your library to just convert every image to PNG, which could be great. I mean, I'm a fan of opinionated frameworks to some degree. Because, I mean, look at this, for example. SDL image is insane. Look at how much dependencies it's pulling, bro. I mean, obviously, it's not using all of them. Like, you could basically, since we're building this in source, we could actually enable and disable the image types we want, which is pretty cool. But yeah, that's just something to consider, I guess. But for now, let's just go. So next, where are we going to go? To SDL TTF, I believe, right? Well, so we're going to say SDL TTF, well, TTF, external, and then we're going to run the get modules there too. If you don't want to do this, then you could just like basically clone all those dependencies on your own library and then tell those libraries or like where it could find them. But yeah. And it's done. Now let's try to reload CMake and see if this works. Now, obviously, we could have just used like binaries, but the bad thing, wait, no CMake ASM NASM compiler could be found in SDL image here. So it looks for a NASM compiler for what? David, what is that? Why? Where's this David library anyways? What it's using it for? David. Honestly, I feel like maybe we should just remove SDL image, honestly, and only support PNG, because this is insane. Or apparently, wait, we could also do maybe David ASM to off, and maybe that would work. Like, we wouldn't need an ASM compiler, whichever the hell. Now, obviously, it would have been better if you have a compiler, like an ASM compiler, so it could basically kind of optimize some sort of maybe image format or whichever here. I'm not sure what it's about. Okay, so enable to find an assembler. Install. Oh yeah, it's for AUM. I don't even remember. I remember I researched this AUM. I don't remember what it is. Okay, so for Aviv. So they're basically doing assembly for that one. Interesting. We could just turn off Aviv then, I think. I think if we just turn off Aviv, it would just work out just fine. Yeah, I remember I did like a tutorial maybe like a year ago or something, you know, using SDL image. And I remember having problems with this, and then I fixed it through some variables. And it's still freaking complaining. Okay, let's just do both flags. Fine. My God. I'm not sure with this David thing too, either. Like, what the heck is that, bro? Is there a README here? Okay, so David or whichever is an AV1 cross-platform decoder open source. Interesting. Bro, really? So it's still trying to. Okay, you know what? Maybe we should just try to install NASM then. Fine. I give up. I mean, I get it, like, but I think it's definitely you could probably like turn off some feature in SDL image and then you wouldn't have to install an assembler. But I just for the life of me, I couldn't figure it out here. So fine, let's just go with stable or whatever. Wait, what the heck is this? Should I go with the Win64 or that's just the source code? Okay, there you go. Executable only or installable? Meh, just go with the installable, please. I don't want to set up the path and all that crap myself. Sure, fine. So apparently it's wanting privileges. Fine, who cares? Let's run as administrator. Yes. Sure. Whatever. And that's that. And now, I believe if maybe I quit CLine to update my environment, it should work now. Should hopefully find NASM. If it doesn't, then we gotta find a way to tell CMake where it could find it. Though, I mean, if I go to a terminal here, can I actually reach NASM? No, I can't. I wonder if it's gonna find it. But we'll see. Oh, I actually just realized you could just say DAOM target CPU generic. Why I didn't read, bro? I feel old. I haven't seen installer in years. Jorion, welcome to live stream. You know what? Let's add a few things here. Why? How about we just add that? I didn't notice it before. This is the joy of CMake. Obviously, if I didn't include SDL image, it would have been just fine. I wouldn't had any problems with any of this crap. In fact, like my prototype, I didn't use SDL image at all. And what the heck? Okay, so you know what? Here's what I'm gonna do. I'm gonna include all of those flags. And I'm gonna turn all of them off. Right? And then I'm gonna clean the build directories and reload the whole project just to make sure. And let's see if that works. What the heck? So it's trying to find an wait, what the wait. So NASM. It couldn't find NASM for whichever reason. Okay. So let's try to add it to the path. I believe maybe the installer for whichever reason it didn't add it to the path. I'm pretty sure. Yeah, it didn't add it to the path. Okay. I mean, I used the installer for a reason, but apparently didn't do his job, so fine. Okay, and let's go. Now, if we go back to CLine, and in fact, if we open up a terminal, we should be able to use NASM too. Perfect. Okay, so I have NASM now in my path. Now it should work. But wait, before that, since we're having NASM now and crap like that, Then let's just enable all that crap. Fine. I mean, we did the work anyways of installing NASM and adding it to the path and crap. But yeah, I do remember I had like a tutorial. I'm not sure how I fixed that, unless if maybe SDL image like changed over the years. And in fact, it did change a lot, like SDL3 and stuff, to the better. Oh crap. It even requires Perl, bro. What the heck, man? You know what? I think I'm just gonna remove SDL image at this point. This is absurd, you know? This is absurd, man. So I'm just gonna ask how to remove a submodule. I think it's a module RM, or well, it's a module remove. So apparently you have to do all these steps for whatever reason. Yeah. Okay, fine. So dnet-f, and we're gonna do third part, well, SDL image. I mean, we could have installed Perl and Crab, but this is getting absurd at this point. You gotta install a whole freaking tool changer just to get it to work, which is a no-go. rm rf-f. We're in 2026, and Git doesn't give you a pretty direct way to just remove a submodule instead of having to go through all this crap. But yeah. Why the heck? Okay, cool. And we're just gonna remove STL image from this. Because what the heck was that, bro? Just to compile a library after installing an assembler in Perl? No way. And the thing is, I tried to like disable avif and all that crap, but it just didn't even respect it at all. And it's even trying to find Python for whatever reason, which obviously I don't have here. But yeah, I think it's just configured properly now. If we try to build this now, cool. Now let's just link all of this. Oh my, I wonder how much time I spent on this. Okay, 30 minutes already. Okay, so private, and we're gonna go with SDL3 and SDL3 TTF, and finally Yoga Core. Fine. And let's just build this. Now this should work. There you go. It's building right now SDL and SDL TTF. As long as you have ran the external script here, the PowerShell script, we're getting the external modules rendered on. And here's Yoga compiling to perfection. And let's go. Okay, cool. So what we're gonna do right now, we're gonna create a directory called src. And by the way, for this third-party thing, what we're gonna also make sure to do is, if you are on CLine, mark that directory as excluded, or library files, actually, as library files. Jorion, I wonder if the maintainers use some Debian offshoot. I recall they come with Python and Perl installed. Yeah, Linux definitely comes with a lot of crap installed too, but like Windows, on the other hand, at least for development, Windows comes with a lot of bloatware installed, and Linux comes with a lot of development stuff installed. Especially if you go with the newer distros, but yeah. All right, so what are we gonna do now? So I believe we're good. Okay, so let's just add well, we're also gonna need the include directory and an examples directory. So for the include, I'm just gonna remove this stuff, I think. Yeah, we could just do it on our own. Just remove them. Not your business, bro. And what we're gonna do, we're gonna create a new file here, which is gonna be like, I think kodachakuui.hpp. Gonna add to git, and in the src we're gonna have kodachakuui.cpp. We're gonna add, and in the example we're gonna have some examples. For now, I think we're just gonna have a simple example.cpp or demo.cpp. And there you go. And yeah, okay. So now instead of library.cpp, we're gonna go with src/kodachakuui.cpp, and then we're gonna target include directories kodachakuui. Well, not private, public, I think, include. And there you go. And in fact, target link library, since this is a library, we gotta make sure to do it public. So we could expose SDL and SDL, TTF, and Yoga to, because I'm honestly not gonna try to hide these. I'm not gonna try to hide Yoga from the user of the library or SDL or whichever. This is just kind of a wrapper library. I'm not a fan of hiding stuff. So yeah, okay, because you just waste a lot of engineering time and all sorts of things on hiding. I mean, yeah, there is definitely a reason for that, for ABI compatibility and all sorts of crap like that, and stability and so on. But I think if you don't want to upgrade and stuff, just don't upgrade too simply and call it a day. Why overcomplicate stuff? Anyways. Okay, I think we're good now. And yeah, let's add an executable now. And if we are on the top directory, I forgot the CMake variable. So let's ask AI really quickly. CMake variable that tells me if CMake is open top level there. What the heck? No. There you go. Modern alternative. So if this is the project is top level, meaning that whoever is using the CMake is actually like inside like Kodachaku as the root, then they're gonna grab the examples. Otherwise, if they're just pulling it as a dependency, they're not gonna compile the examples and so on. So if project is top level, then we're gonna add an executable, which is gonna be our well, what are we gonna call this? I don't know, Kodachaku demo, I guess. And speaking of, or you know what? I don't know. Let's just do this. Yeah, and what we're gonna do next is we're gonna include examples / demo.cpp, and then we're gonna say target link libraries, the demo. We're gonna link it to Kodachaku UI, and we're good to go. CLine with its inspection crap, but yeah. All right, so now if that works, we should grab our where is that? The demo. There you go. And we would have like an int main here, right? Well, we're not gonna use int main actually, but just for testing right now. This gotta be, make sure to say pragma once, obviously. And other than that, I think we're good. Now let's just try to include that. So include kodotaku.ui.hpp and run it. Perfection. Okay, cool. So now what we're gonna do, we're gonna come to our third party SDL examples, and there's a template right there. We're gonna grab that template, we're gonna put it here, and then we're gonna come here, highlight only syntax, and boom. So we're gonna copy this SDL main use callbacks. And honestly, I'm gonna make a little helper for this at some point. Yeah, I'm definitely gonna make a little helper for this for people who uses this library, but yeah. But either way, let's just do this. So you're gonna have this app init. So instead of int main, you're gonna have app init, and you're gonna need this SDL app result and app event and app iterate and app quit. Right, sick. And then we're gonna basically have a class app. All right. And what we're gonna do, we're gonna set the app metadata. Well, not here actually. Let's just wire this thing up, okay? So we're gonna say std unique. Well, I believe we could probably just say auto app is equal to std unique ptr. This AI inline crap sucks. Wait a second, how do I disable it? Okay, so let's go with the unique PTR here, and we're gonna go with, well, actually, we're gonna go with make unique, my bad. Make unique app, and I believe we could just say class app like this, right? Or what is it? Invalid application of size of to incomplete type. I mean, fine, let's just grab this class app and put it here. And so we're gonna say make unique app, and it's gonna have a constructor, obviously, which gonna takes in an std span of char, char pointer, and this is gonna be your args, you know, program arguments, and we're gonna add this span here. And next up, you can also have this app destructor. We're gonna need a few other things later on, but for now, this is good. So std span, we're gonna pass in the first and the count. So the first here is argv, and then argc dot static cast. And you're gonna static cast it to size t, and boom. Okay, what we're gonna do next is, after creating the unique pointer for app, we're gonna, well, we're just gonna return SDL app continue. Right. And we're gonna make sure to say app.release. You know why release? Because we're gonna release the ownership, so it doesn't, like, it wouldn't destroy the application after it exit this scope, because we want to set it to app state here, because the release gives us back the actual pointer, I believe, right? But obviously you got to dereference this pretty much. And yeah, I guess that's it. Is there anything else here? I think we're good. Now, next step, what we're gonna do, so we're gonna say cd unique ptr app, and we're gonna pass in the app state dot static. Well, I think probably reinterpret cast, but let's just try static cast anyways. See if it could do that, because I can never remember all the rules, and apparently it seems to work just fine, so that's great. And then what we're gonna do, and obviously we also gotta have try catch and stuff, because we're gonna be using what is it called, exceptions. So we're gonna say try, and then we're gonna catch exceptions. There you go. So we could just do it like this essentially. And if we got an exception, we're gonna return SDL app failure. And that's that. So here we're just gonna say app release. Can we do that? Yes. But obviously, what we're gonna do before that is app.event. And then we're gonna pass in the event. So we're also gonna have like event. So auto event SDL event. The users of our library wouldn't have to do this because I'm gonna include like a little header that you could just include it, wire up all this crap for you. This is essentially kind of like the plumbing between SDL C API and the C++ way of doing things, kinda. But yeah. So there you go. So this is gonna be like more of a UI library. It's gonna also give you a little bit of helpers, but yeah. Okay, so what this would return exactly would return, I think probably nothing, or should we go with, yeah, I think nothing. Could go with nothing, I believe. Actually, no, let's just go with SDL app results, fine. SDL app results. And in fact, I'm gonna make sure I'm using the trailing return type for all of these. Whoops. Chain convert to trailing return type. Convert to trailing return type. And okay. And that's good. So this is going to be basically auto result is equal to that, and then we're going to return that result. Now the app event, why this is not working out exactly? What? Why can't I access that? Okay, so I gotta do that, fine. Right, app release, and I don't want to use this, just say void. Should not be disregarded. You know what? How do you disable this crap? Da, 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 da. And let's use try for this too. So we're going to use try here and catch. And we're going to do the same thing again here. So try, then catch. And finally for the quit, we could still say try and catch too, why not? But we're not going to return anything. And yeah. So that's the event. We need also the iterate. There we go. This is the iterate. So we're gonna go with auto iterate, and it's basically gonna return an SDL app result. And yeah, so what we're gonna do here, we're gonna do a very similar thing to here apparently. So we're gonna try this and app iterate, and we have no event here. And we're gonna release the app. You know why I'm doing this unique PTR stuff here? So if we like, basically inside of these methods, if you throw an exception, that it's gonna basically be cut, and then the application would get this like, you know, cleaned up, destroyed, right, properly. Otherwise, if we quit to back to SDL, we're gonna release that pointer back. So until we enter the callbacks again. This is kind of the point here, essentially. Anyways, so what we're gonna do next here, well, for the application, well, we're gonna make a little exception, SDL exception here. So this is gonna be std runtime error, and I'm gonna go with SDL exception. And here we're gonna have the lock. So for the lock, we're gonna go with std source location. Lock, wait. There you go. And let's just include that header. And then we're gonna initialize runtime error with a message. And this message would use std format. And let's include format there. Yeah, why it's not? Bro, that's stupid. Anyways, let's just do it ourselves then, fine. You suck. Alright, so now what we're gonna do, we're gonna use file name, which is gonna be, well, not that, we're gonna use this, and then a colon, then the line, then a colon for the column, then another colon, and then finally we're just gonna go with the error, right? The SDL error. So here what we're gonna say is lock.filename, and then lock. Line, and then lock.column. And you know what? Why not? Let's include the function name too. Who cares? And then finally, we're gonna go with the get error, SDL get error. And let's include the function name too here. And there you go. And I believe that's all. Pass parameter by const reference and make this explicit, right? There you go. And yeah. Now, what we're gonna do? Well, next what we're gonna do is we're gonna wire up the SC out and CERR. So basically the standard streams for printing and login and stuff, we're gonna wire them up to C++ streams. So instead of saying SDL log error, SDL log, etc., you could just say stdc out, and then under the hood it would do that for you. So how do we do that? Well, we create a stream buff. And let's do that. So SDL log stream buff, and it's going to basically inherit from stream buff, I believe. And then we're going to generate some functions here. Whoa, G Gearin, welcome to live stream. Okay, so we're going to generate some code here, and we're going to override some members. Lehislegir, welcome to live. I'm curious why use C++ when there are new low-level languages still compatible with C, like Zig, Odin, Rust. Because there's such a huge pain in the ass, because like a whole lot of the ecosystem is inside of C++. Like if you want LVM, then you got C++. If you want, you know, Vulkan libraries, C++. SDL is also the best open, like cross-platform abstraction you're gonna find. Not even like WinIt in Rust, it's not even close. And like you could definitely use SDL, let's say, or LVM from Rust or Zig or whatever, but you're always going to have a lot of friction with the build systems, with the conventions, with pointers. So you always find yourself in the rut with raw pointers and stuff. And for that, you just use C at that point. But the nice thing about C++ is that it kind of like, it's not perfect. I really kind of hate, like, I have a love-hate relationship with C++. That's for sure, and CMake. But at the end of the day, it just gets the job done. It really is the best we have for bridging between C libraries and C++ and all this bull crap. Yeah, it's just literally the best we have. Rust, on the other hand, I really love Rust. Don't get me wrong, like it's my favorite language. And honestly, in another world, I would have used Rust forever. But I'm a perfectionist. I'm actually having a lot of problems with perfectionism because I just can't get any project done because I just never feel that it's enough. And like I quit hard like halfway and all sorts of things. And Rust is not making that easier. Rust like just constantly nudges you in this compiler perfectionism stuff that you gotta make sure that this ownership is right and that just kind of really hinders your progress a lot because it just doesn't accept just partial solutions. You just gotta always have a perfect solution up front. And in Rust, if you gotta deal with some raw pointers or like raw libraries, like let's say Vulkan, then you gotta either find some binding, some safe binding that someone else have done, which then it means that you gotta depend on that person on maintaining that binding. If he quits, you're done. You gotta figure out to like maintain it yourself or whichever, or just use another one. That's first thing. Second thing is that if you use the row pointers directly, yes, you could use the row binding directly, but then you constantly have to stay in safe this, in safe that. And yeah, it's just a pain in the ass, just a lot of friction. That at the end of the day, I just gave up and just gone with the mainstream, which is C++, the standard, essentially. Same thing with CMake. I believe there is definitely better options than CMake. Meson is better than CMake to some degree, especially in C. Like configuration in Meson is way faster than CMake. Um, and it uses pkg config by default, which is quite nice. I tried Meson too, so it's a little nicer step than CMake, and it also kind of uses like some sort of a syntax like Python, which is nice. CMake syntax is all over the place with quotes and stuff. The other thing, there's also Xmake that I actually tried. This is the last build system I tried, and it was such a joy to use, Xmake is very nice, very cool. So instead of having to go submodules and do all this sorts of crap in CMake and all sorts of things, what you do in Xmake, you just add require SDL3 and boom, it just works. Yeah, so like you just say require SDL3 or require Skia or whichever, and it just works. Boom, it works. So you basically use Lua to build your stuff. And in fact, let me show you really quickly. And it just downloads the stuff it needs itself. Like if it needs Python to build some dependency or stuff, or like an assembler or whichever, it doesn't ask you to download it on your system like CMake does or whichever. It just does it itself. And honestly, it's quite lovely for your own personal projects, but obviously for like your own program, or like especially like a library that you want to share with the ecosystem and stuff, you just gotta go ahead and just use CMake, which is the industry standard. But yeah, I really recommend checking Xmake if you don't like CMake, then that might be your dream dream build system. It's pretty sick. Like you could get a lot of stuff done in a few lines of Lua code. But since I've already gone through the crazy years of dealing with CMake and I kind of learned through it and everything, yeah, I'm just gonna stick with CMake for now. But yeah, that was just a little tangent. If you guys have any other questions, please let me know. But yeah, I kind of explored a lot of technologies along the years, so I have an idea of why I choose this over that at any single point in time. But yeah. Anyways, next up. So essentially here we want to implement this stream buff. How are we going to do it? Well, we could basically implement all these functions, but the only functions that you really need to implement here is sync and I believe overflow. Yeah, overflow here. So these are the only ones that you really need to implement. And honestly, I can never remember how to implement this. So you know what we're gonna do? We're gonna ask the AI to do it. But let me just explain to you what's going on here. So essentially, this overflow function, it triggers when it wants to add a new character into the buffer, right? And this sync function, it's when you say std end line. So let me actually try to explain this. So you know when you say stdc out, right? And then you use the stream operators. Let's say you say hello, and then let's say you say 1, 2, 1, 2, 3, or whatever, etc. You got the point, right? So you could use numbers, strings, all sorts of things. So these kind of operators right here, they're not actually doing the job for you in like putting that into the like printing that stuff. No, they're just translating all of these stuff, these numbers, these strings, or whatever, into a stream of characters, right? So hello, it would give you HELLO, and then for number 23 it would give you a character 1, character 2, and then character 3, and then it pipes it in into cout. And cout, what it does, it basically uses a default stream buff that is provided by the runtime, I think, or something. I don't know. And it basically triggers your overflow function, and it gives you these characters. And then what you're supposed to do is you're supposed to buffer those characters into your own buffer. So here's how you do it. Basically, you say string, I think, right? Or isn't it? Yeah, okay. You could use string, vector, you name it. You could use whatever the heck you want. And then what you're supposed to do is you say buffer plus equals C. But if if C is equal to a new line, then you're kind of supposed to essentially flush the buffer, right? So flush the buffer. And in sync, same thing. You also gotta flush the buffer. What I mean by flush the buffer is that you should just write what the characters you buffered into the actual system. And we'll see how we're gonna do that. Right. So we're gonna have like a function here called flush buffer. And how are we gonna do this? Void flush buffer, right? And what we're gonna do is we're gonna use here SDL log priority. And what this SDL log priority does, wait a second, what's going on here? Why I don't get that's weird. Oh yeah, that's why. So I guess let me comment this out for a second. Okay, so this is the log priority. Wait, why it still doesn't give me the complete autocomplete? That's strange. Oh, that's an enum. Okay, that's an enum. Log message. I'm sorry. And I'm like, what the heck? What's going on here? Anyways, and then here the category. And for the category, you got to use your application category. And for the priority, here we're going to grab it from the constructor. So we're going to have a priority and then the actual format thing or the string that you want to write. And in this case, we're going to go with an S format and then the buffer. And obviously buffer C string. And there you go. And for the priority, obviously we're going to store that. So it's the log priority, priority. And we're going to grab that through the actual constructor here. So basically here, I mean, this is not like 100% required. Like you could go with your life without SDL, like logging, and you could go with your life without the main callbacks and all these sorts of things. But I'm kind of teaching you how you could bridge the gap between a C++ API and a C API in a perfect way. So instead of having to deal with the C++ streams, you use SDL log message. Why? Because SDL would make sure that the login is cross-platform. On the other hand, the standard library, no. Like for example, SDL on Android, it would make sure to use logcat. On Windows, it would make sure to use output debug string, so you'd see it in your Visual Studio console, etc. So depending on the platform, it would make sure to use the right logging. And so instead of having to use in our C++ project ourselves SDL log, we could just use std cout, and std cout would use SDL log. So this is why we're doing this, essentially. But yeah, and here what we're gonna do is priority, and we're gonna set the priority, and there you go. And I think this could be constant, fine. And here you gotta return some crap that I didn't understand, but we'll see about that. And in flush buffer, you just obviously, and after that, you just obviously just like clear the buffer. And that's all. Now, what I'm gonna do, I'm just gonna feed this into AI, so it tells me how to do the rest of this bullcrap here. Let's see. Complete this implementation and tell me why. Because I actually learned about this stream buff just recently through the AI itself, because I was like, how can I bridge between SDL logging and SDL login? And it tells me, and this is how you're supposed to do it. It's this weird thing, trait types EF or whatever. I didn't really understand what the heck is that. So I guess we'll figure it out. Public inheritance. The original snippet inherited implicitly via class stream, which defaults to private inheritance. This would prevent the code from cheating your class like standard stream buffer. Oh crap, okay. So this is the first thing I forgot. Gotta make sure to make this public. Otherwise it would be implicitly private. Yay. Next step, what we got is handling trait types EOF. In overflow, the input parameter C can be EOF. Usually when the stream is flushing out data or closing. Adding EOF directly to your string buffer introduces garbage characters. You must check for EOF first and convert C back to a proper char via traits type to char type. But like why? But we'll see. Okay, so you gotta basically check if C not equal to trait types EOF. So if C not equal to trait, or I think you could just say if it's trait types EOF, then you could do something, I guess. You could just return trait types EOF then, I guess. Is that what you want here? But they're also doing this weird trait type to char type. Okay. I'm not sure why they're doing this weird crap. I'm pretty sure there's a good reason to. But yeah, that's that. And honestly, this constant crap is just so annoying. Let's just remove it, bro. Disable the inspection. And no return statement in function, blah, blah, blah. Let's see what we got next. So I think we're done with this point, right? Next step you got here is sync. If not buffer empty, then flush buffer. Otherwise, return 0 to indicate success. Okay, let's return 0. And basically, if empty, if not buffer empty, then, well, honestly, we could do that in flush buffer itself, really. In fact, I think. If not buffer, well, we could just say if buffer empty, then just return. Too simply. And yeah, that's all. And I think that's pretty much it. Did I miss anything here? Oh, crap. Wait, did I fix that part? You also gotta return C though. Huh. Wait. Or you know what? We could just give it this and ask it what we... Control flow, return values, must return something other than on success, return C. Okay, -1 failure, guard empty flushes. Okay. Okay, so we gotta make sure that this have an else. And then finally, we just return C. Yeah. That's all. So we don't like add a new line into the buffer after we flushed it, essentially. And I guess that's all. Right. Okay, perfect. So now the real question is, how do we... what is it called? Okay, how do we switch? How do we make cout and cer use this stream buff? I think you use RD buff and crap, but yeah. There you go, RD buff. And actually, even before that, I want to ask it, why do we need these traits type thing? But we'll see. When you pass a pointer to a new stream buffer into RD buff, it swaps out the old buffer and returns a pointer to it. You must save the old pointer and restore before your custom buffer goes out of scope or the program exits. If you don't, stdcout will be left pointing to a deleted memory address, causing a crash. Yeah, because like it could... Yeah, I see. Anyways, here's the cleanest way to do this using an RAI manager class to safely automate the setup and tear down. Ooh, RAI manager to redirect the stream safely. Okay. So like on my first attempt, actually in the prototype that I made off stream or a camera, I just done this like implicitly, but here it's like telling us to use RAI, which is quite nice actually. I see. So this is basically how we redirect from cout from the regular buffer to our log SDL logger kinda. So here you change it to redirects and save the original buffers, but you keep the original buffers that were there before you set up the SDL logger. And then after you're done, you restore the original ones. And hello, Yo-Yo Man 3D, good morning. And good evening. Anyways, and we prevent copying, yeah. Yeah, that's pretty sick actually, I love that. But since there are extra, everything inside the scope redirects to. Yeah, lovely. So inside the scope, anything where you use like cout and CRR, it would use SDL log. Have you ever tried WGP Rust? Definitely, I did. Yeah. Key things to watch out for: end line versus new line. And oh, by the way, did I actually mention what sync is for here? The sync override is basically for when you say new line, when you add STD new line here, it basically kind of like triggers this sync here. Or like if you also use STD flush. But on our hand here, we're also making sure that if there is a new line, we also flush the buffer. But yeah. Anyways. All right, so honestly, I think I'm just gonna copy this guy because it's so convenient. So convenient. So class is DL exception. And let's just remove this from here actually. Wait a second. Let's add this guy. Include IOStream. And no need for these comments, I think. And prevent copying. And notice here that we're using this guy is the log stream buffer, right? And for the cout, we're using priority info as the log priority info. And for the CERR, we're using the log priority error. And that's how it works, essentially. And yeah. Is there anything else here? Okay, so now the real question is... Okay, I'm going to ask it a few questions. First of all, about the traits type. What that traits type in streambuff4? And also, how about the other overrides? What are they for? Okay, so I guess maybe instead of like implementing streambuff, we could actually implement any kind of char, maybe even like QTF or whatever, I guess. Is that the case here? For the stream, provide standardized set. Oh yeah, so basically your stream buff could handle both char and wchar-t, for example. It could be generic if you use those traits. Oh, okay. To optimize C functions. Interesting. So this one, excess put in, is for mask bulk writes. When you type hello world, the stream defaults to colon overflow. So this is the one that we actually overrided here. Sorry. Sequentially for every single letter in that string, overriding excess put n allows you to intercept the entire array of characters at once. So basically, instead of calling overflow for every character, you could, if you override this excess put n, then it could give you this whole buffer in bulk at the same time. Yeah. Enderflow inputs. This one is for CIN apparently, which we don't care about, I think here. I don't think like SDL gives us CIN stuff. I don't think. But yeah, this could definitely be used, for example, for sockets. Like I could do that. But anyways. And set buff, provide an external custom memory buffer array. Okay. So if you also like provide these, then it kind of becomes random access instead of just linear. Seeking make no sense, so you leave them alone. Okay, so you could add this excess put in apparently, and what it does here is that it grabs this char type and the n, and then it creates a string view from the s and the n, and then new line pause. So it finds the new line in the string view, and then if we found a new line in the string, then no new line found, just cache the entire block. Cool. Otherwise, what it's gonna do is append the text up to the new line, flush it, and process whatever remains. That's interesting. I see what it's doing here. Buffer append as new line pause. I mean, this is an optimization, honestly, because like you could just use just only these methods, like the overflow here. But this is a little optimization if you'd want it, essentially. Yeah, recursively handle the remaining characters. What? Wait. So it appends everything up to the new line, and then it flushes the buffer. And then what it does, if new line pause plus 1 is less than n. Oh, right. So I didn't actually account in my brain for other new lines existing. So like when you have this excess put n, like it could contain multiple new lines in theory, not just one. So what they're doing here is if it's not the end of the buffer or the string yet, then we call excess put n again for the rest of the string. Though here it could have used the string view. Yeah, there's some interesting methods here. Yeah. All right, let's actually try this out. Let's try it out, really, fine. Just for the case of like, learning. So how are we gonna do this? So I'm gonna come here, generate code and override members, and we're gonna go with excess put n. Right? And I don't care about you, C-line. Get out of my way, please. Disable inspection. Okay. So what we're gonna do here is we're gonna create. So here we got a pointer and a count, and this is a prime example for using a string view. You could basically it just bundles out, because like string view, what it is, it's just a pointer and a count. That's all. So it's a non-owned string. So what they call it here, they call it just view. Okay, fine. And actually not, wait, yeah, view. And you just gotta give it the pointer and then the count. And that's your view. Now what we're gonna try to do is we're gonna try to find, is there a split function? Like what's there? Hold on. Yeah, there's only like find, I think. Yeah, just there's even substr. Okay, so let's try to find, and we could say first or last. Yeah, let's just go with regular find, please. And what we're gonna do here, so we gotta give it a string view, the right, and then the offset, where to start the off. Okay, so we're gonna try to find essentially, we could give it a char, which is like a new line, and essentially, if it's a new pause, is that a end pause? Sorry. So if we couldn't find it, then we're done. Then we're just gonna like buffer append. Sure. Then we're just gonna say buffer dot append. Append what? We're gonna append the view, I believe. Else, it means that we do have some new line character here. And at that point, what we're gonna do, we're gonna append everything up to the new line position. So this is the new line pause. New line pause, okay. Auto new line pause. I mean, we do have subster, but we don't need that. Hold on. Buffer dot append. Append what? Append s up to new line pause. So that's the offset. Okay. The view, I believe. Right. Wait, hold on. And then we flush the... Wait, is that the offset or the... No, that's the offset. I don't think that's right. I mean, there's the offset and then there's the count. So what we want to do here, if there is the new line, then we're going to go from 0 up to... Okay, I think probably did a mistake here. Probably did a mistake. But to be honest with you, I would rather just maybe do s is equal to view dot subster, maybe. And then here the offset is 0. Then the count. But what if I just give one item? It's just offset. Okay, so I'm just gonna go with 0 up to new line pause. So it's actually the same shit, so fine. Let's just keep it that way. Yeah, I think it probably made the wrong move there. I think you made a mistake. Check the signature. I'm just making sure. Yeah, okay, let me give it the actual that it's talking about, fine. Let me give it this actual overload. Because I gave it the wrong one. That's why it's telling me that there is another overload. Oh yeah. No, you got an excellent technical detail referring to Microsoft MSVC STL. Oh, really? Bro, it's just... I swear to God. This is stupid. No, it's offset, bro. It's offset, my God. Okay, don't trust the AI. Anyways, never mind. Next step, what we're gonna do, we're gonna flush the buffer. And okay. And next, we're gonna basically, if new line pause +1 less than n. What's n? Oh, the stream size. Okay, so if new line pause +1 is less than count, then we're gonna say excess put n again. Excess put n what? The pointer here, which is gonna be s plus new line pause +1. And s here is basically PTR. So here we're basically just grabbing the pointer, the original string pointer, skipping through or over the new line character. And yeah. And then up to, and the stream size is n minus new line pause -1. I think we could probably make this more readable, to be honest. Because this is insane. Maybe. I'm not sure. I mean, like, if we do, I don't know, like, I guess... so we have our view. So basically what we want here is you want to substr. I mean, I think you're gonna basically do something very similar here. You're gonna say like new line pause +1, essentially, comma, and here the count. Count is gonna be the count minus. Yeah, nah, it's just gonna be a very similar thing. Anyways, whichever. Anyway, who cares? So I think this should work fine. And then finally, we return the number of characters successfully written. But wait, how about the... Okay, fine. Let's just say return n. And let's go. Add const. And fine, whichever. And yeah, that's basically it. And actually this should be count. There you go. Now we should be able to do this. And I believe we gotta basically add, I guess, a static, maybe? Or what should we do? Yeah, I think we could definitely add. Should we add it now as static or what? I mean the logger. Or maybe should the user should do that, okay? All right, fine, that makes sense. That makes total sense. So SDL log redirector app. That makes total sense. So we're gonna go with private, and then we're gonna have an SDL log redirector there. And we should be able to like try this out by simply saying stdc out. Hello. CD end line. And same thing with CERR. And I guess that's that. Can we actually run this now? Okay. Let's return SDL app continue, please. And return SDL app continue here for the event. And result externals, Kodotaku demo main. Well, I see what's the problem. This should be defined first, before including SDL, I believe. No? Or isn't it? Do I still have maybe main function here or something? And result external. Or could it be that we need to like possibly link directly to SDL? Is that the case here by any chance? No, doesn't make any difference there. Did I include SDL main? No, I didn't. My God. Okay. Now if we include SDL main, and boom. But we have a little problem that I forgot, which is if you debug this, you're gonna have a DLL problem. Yay. Okay, so this is only in Windows. And what we're gonna do, make sure to do, is to basically like copy the DLLs, and I could never remember the cmake command. Copy SDL DLLs. Come on. And there you go. I'm just gonna copy this bad boy. I'm gonna come here, and we're gonna do it for the demo, right? So yeah, add in a custom command to that target, Kodotaku UI demo. And for the post build, so basically after the build step, we're gonna use the cmake command. We're gonna use the copy subcommand of cmake, which is cross-platform way of copying. So instead of saying cp, which only works on Linux, or whatever you have in PowerShell, you just say cmake-e copy. And then you give it the -t, the target file. And here we just use this target file directory for Kodotaku UI. So basically this would give you a variable that basically resolves to the directory where the Kodotaku UI, I guess the binary place or whichever. And then here you got the target runtime DLLs. But either way, this works, right? So let's go. And now this should work out just fine. Let's run. Okay, so that was a insane detour. And boom. So we got error hey and we got hello, which is perfect. Lovely. Lovely. And just to show you that it actually does work for sure, maybe what we could do, and in fact, I wonder if it's using access put in here. So here's what we're gonna do. Just to get a little idea here. And what else? Yeah, I think we're good. And boom. All right, so here, first of all, we got excess put in. So it uses our excess put in, and then one overflow for whichever reason. I'm not sure why. And then it says hello, and then sync. Oh, sync 2 times. Why? Weird. Excess put in, sync, error, hey. I wonder if that's right. Like, hold on. That's a lot of syncs right there. No, that has nothing to do with that crap. The AI is really drunk, bro. Anyways, I just wanted to verify. You're completely right. There you go. It's actually working perfectly now. I'm just wondering why there are multiple syncs there. Sorry, by internal pointer mechanism. Oh, okay. Interesting. So basically, if you use CER, you could flush the C out too? What the heck? So it's working fine. Just wanted to make 100% sure. All right, fine, cool, lovely. So there you go. This is how you implement a custom stream buff. Perfection. Now, what we're gonna do next? We're gonna do the last thing when it comes to the, glue between SDL and C++, which is using SDL malloc, calloc for C++ new, delete, etc. So yeah, and for that, add explicit. Right, hold on a second. Okay, back. So this just this fly really annoying me because it's just so hot in here. The temperature is insane in Morocco. But anyways, all right. So what we're gonna do? We're just gonna honestly tell it because it's just basically overriding some weird operator crap. But yeah. Okay, now override new and del to use SDL malloc, SDL calloc, SDL realloc, SDL free, etc. Let's see what it's going to tell us or what it's going to give. And there you go. You just do this weird stuff. Over allocation for over aligned types. What the heck is that? Interesting. Anyway, that just boilerplate code. Let's just grab this whole thing. And there you go. The other nice thing about doing this is that you could just use SDL set memory functions, and then it would override even the actual C++ allocations too. So you could route all the application allocations, all of them, even SDL, through the same kind of functions to some degree. But yeah. Oh, interesting. So C++ doesn't have a realloc. Okay, weird. SDL, so alignment handling, types requiring specific boundary constraints or explicit aligners annotations invoke using, all right. Nice, lovely. Okay, so let's just copy these and let's put them here too. And let's just rename these to their original things. Fine. And boom, now all the C++ stuff goes through SDL. And perfection. And yeah, all right, so here's what I'm gonna do. I'm gonna take all this crap, this glue code, and put it in one header which the user could include. I'm actually gonna tell it to the AI even. Extract all the glue code. I want to put it in a header which the user can include to get all that applied. They just define their app class. We'll just assume the class is called app. And let's see how it's going to do it. Kodotako entry.hpp. We forward declare the app. And there you go. That's crazy. And now we could use stdcer sick. Though here it uses stl log. Why? Wait. No, it should be able to use. Why use stl log instead of cer in init and quit? How the user main looks like now. And boom, look at that. So you just include Kodotako entry and you're done. You don't have to deal with any of this bull crap. I use SDL log in because redaction is completely or not for those. What? Oh, okay. Okay, gotcha. Okay, region, but use SDL log error instead of usual log. Because like when an exception happens, you don't know if that's initialized properly or not. Or it could be even removed, yeah, at that point, anyways. No, remove that. Remove any residual debug logs. What else do we do? Or comments? Yeah, that looks perfect. Just making sure everything is correct here. Lovely. Wait. I feel like something is missing for whichever reason. No? Not really. Okay, fine. So this is Kodotako entry.hpp. So let's add a new header here and include. And obviously this is opt-in. You could use it or you could not. This is obviously opt-in. Coda checker entry HPP, and let's just take this in here and boom. Um, yeah, and now instead of that, getting late on my place. Good night, Jorion. Thanks for coming to the stream. Okay, now let's go. Um, well, the log redirection, yeah, okay. Extract the classes like exception and log redirector, buff, etc. into a utility header. So we can include it at the top. Yeah, sick, lovely. Yeah, looking great. So let's grab this Kodotaku utils. .hpp, and I'm gonna add this stuff right there. And what we're gonna do next right here is now the entry header is this. So it just includes these stuff. Cool. Perfection. That this is cannot be declared. All right. And let's just try to use it in the demo now. And I guess now it should probably work out just fine. Application started. Lovely. So it's working just fine. Perfection. So now this is how you create your demo. You just include Kodotaku utils to grab the the exceptions and all sorts of things, and there is the log redirector or whatever. And then finally, at the end of your file, you include this Kodotaku entry, and it looks obviously, I'm just making an opinionated design choice here to make sure that your class is called app. We could make like a macro which allows you to like choose the class name, etc. But bruh. So I'm just hard coding it to app basically, and you just do it. This is what you do in your own class. That's all, really. And obviously include this SDL log redirector, which would make sure that while your application is alive, any logs that you do goes straight into SDL log. So you don't have to use SDL log. You could just use your regular C++, SC out, etc. And obviously also entry, make sure that your logging, your new and free and stuff also works out just fine with SDL, malloc, etc. And yeah, that's cool. It's lovely. All right, so other than that, I think I'm just gonna make sure that to give the warnings that we have here to the AI and see if they have anything to do with anything. So we can actually put those inside. Okay. All right, fine. So the entry should just be that. And apparently there's some reachable code here. And oh, right now it's just using the leech. It's not using that std unique pointer anymore. At least not here. Yeah, I removed those. I mean, interesting. We'll see about that. And then move them into your library source. Since your CodeAttack UI target compiles a static library, embedding, pick up your... Alright, sure. So we're gonna put them into here instead. Alright. That might mess with other libraries, I don't know. That seems working just fine, actually. But one thing we have in here that I have a comment about, I seem to have removed the unique PTR wrapping in iterate event. I added them there, so if the methods like, you know, throw an exception, it would make sure to destroy. But actually, hold on, let me think about it really, because the thing is, if an exception happens, what's going to happen here is that in fact it's going to return SDL app failure, right? But after you do that, what happens is that it actually calls quit. Yeah, it actually calls quit, and then quit would make sure to delete it. Actually, it's good. Nah, I had it wrong, really. Yeah, had it wrong. So yeah, that's basically how it works. Perfect. So now we could go to the next thing. So we basically have done with this bull crap of glue. I will never ever write this ever again. And we're great. We're good. So in fact, let me ask the AI, like, now that we have wrote the glue between C++ login and allocating for SDL, what's the advantages? Just so we could see what we gain from this. Unified engine tooling and crash analytics, a single source of truth. So this is kind of the thing that I'm really looking forward to. You no longer have to log fragments scattered across the terminal, cout, standard error files, and debug consoles. Everything flows into SDL3's centralized login funnel. And in fact, even SDL have like a more interesting logging and allocating facilities. Like for example, you could set an environment variable to change the login priority, or you could reset the memory functions, etc. If you choose to monitor crashes or look at real-time allocation analytics, you only have to attach a single callback tool to SDL, or custom memory trackers via SDL set memory functions, as you can see. Single checkpoint immediately captures every single cout and CERR, or new delete, allocation happening inside your code. Look at that. Perfect cross-platform console containment, handling desktop environments instantly on platforms like Windows windowed graphical applications when main do not have a standard terminal text window attached. By default, this layout means standard cout prints are completely lost or swallowed. Native redirection, because your macros redirect down to SDL log message, SDL3 automatically detects the platform environment and cleanly routes logs to where they belong, like the Visual Debug output stream in Visual Studio, the Android Logcat system, or Apple's diagnostic console. Next up, we got comprehensive memory auditing stability, zero leak anonymity. Every standard C++ container configuration like std vector, std string, custom allocation components uses standard new and delete. Allocations behind the scenes. Moving these allocations over means your engine tracks them natively inside SDL's memory manager. And deterministic lifetime layouts, because the entry setup ensures the log redirector layer maps cleanly to your core app lifetime block. You bypass dangerous initialized memory initialization traps or crashes during global variable teardowns when the framework shuts down. Lovely. Alright, so finally, what are we gonna do next now? Okay, so I think right now we're ready to move to the next thing, which is to actually initialize SDL, etc. So how are we gonna do that? Well, we're gonna open up our SDL thing, and we're gonna look for examples, and we got a template.c there, and let's just put this here. And let's see. So the first thing we're gonna need to call is SDL set app metadata, and look at that. Even the official SDL examples aren't really handling all the errors, which is honestly good for your sanity. But my perfectionist mind can just let me go. I have to handle everything. But there you go. All right. So what we're gonna do here is, if not SDL set app metadata, and here the app name, let's call it Kodotaku demo, and the app version, let's say 1.0, and then com.kodotaku.demo for the app identifier. Let's go. And if this doesn't work, if this errors for whatever reason, we're gonna throw an SDL exception. Let's go. Boom. Next up, we got SDL init. So SDL init, we're gonna say SDL init video, and then we're gonna log couldn't initialize SDL. Honestly, I'm just gonna throw the SDL exception. That's all. Call it a day. That's that. Next up, we got create window and render. So how much control does that give me? Yeah, all the control that I need. Sick. Okay, so we're gonna have like an SDL window, and SDL render. For now, we're just gonna use the SDL 2D render, not SDL GPU, and that comes with its own kind of advantages. First of all, it's easier to use for 2D. And second, it's very optimized by the SDL team themselves. And third of all, it does work on web too. While SDL3 GPU, I think they don't have support for web just yet. They probably would at some point in the future, but not now. Anyways, and in fact, it's using like SDL GPU under the hood. Though if you actually want to use that, you got to use a proper function for that, not the regular one. But yeah, there is a route for that too, if you ever need that for whatever reason. But either way, for now, let's just go with the default way of doing things. And for the title, we're gonna go with Kodotaku demo. And the width, let's go with whichever, 800, 600. And the window flags, we're gonna go with SDL window resizable to make it resizable, and we're gonna make sure, whoops, what the heck did I do there? Resizable. Then we're gonna go with SDL window hidden. So it's gonna be hidden at first. And then we're gonna show it after we make sure everything is ready. Like that we're ready to draw into the screen. And yeah, that's all. I think throw SDL exception. What? There you go. Boom. Obviously here you gotta give it, I think, yeah, a pointer to your window and a pointer to your render. And there you go. So this is essentially a pointer filled with render or null on error, true or success, or okay, sick, lovely. And that's basically how it works. That's how you create a window and a render. And if you want like some fixed resolution or aspect ratio or whatever, could be useful. For example, let's say a video player, that you could use this SDL set render logical presentation with whichever you want. For example, here letterbox, perfect for let's say video player. And here the width and height, you could just set it to, let's say, the video dimensions, which is pretty cool. So you don't have to do it manually yourself. Lovely. But we don't really need that in our case for now, at least. Other than that, in the event here, what we're gonna do is, instead of using an if, I'm just gonna use a switch. And I'm gonna use like switch on the event type, and in case we have SDL event quit, then we're just gonna return like SDL app success. Otherwise, if we have like something else, then just gonna continue. That's all. Now for the iterate function, what we're gonna do? Yeah, just app continue for now, but we're gonna add some few things. We're gonna add, well, if not SDL app, well, not app, SDL render, set render draw color. And also I'm gonna use the float ones, notch and render, comma, and then let's go with just a red background for now, just so we could make sure that it's working out. And if that errors for whichever reason, although most of the time it never does, but just in case, we're gonna return an SDL exception. But also, instead of doing this every time, I'm gonna make a little function in Kodotaku utils. I'm gonna call this function check. So let's see, void check. And this check would take in an SDL bool or just Boolean result. And if not result, then we're gonna throw an SDL exception. Right, and we're gonna also have another overload for this, and it's gonna be using a template for the pointers. So I believe we could use type name t, right? And then you're just gonna have like check t. And honestly, let's just use the new way of doing things. I could never remember. It's not a big deal, but I'd like to keep it consistent as much as possible, but yeah. So if not results, well, actually here, instead of this, we're gonna return just directly t. So otherwise, we're just gonna return, well, the results, obviously. And there you go. And yeah, that's that. Sure. And boom. So now what we could do is, instead of this business right here, we could just say check. That's that. Check this. And check that. And oh my god, this is much better. And we're gonna do a similar thing for this one too. Check. Well, let's just remove this SDL exception here now. And boom. Okay, that's way better. Now, if we run this, well, actually, I gotta continue the program first. And whoops, we have actually a problem in here. Oh, what? Okay, let's remove that. And look at that. So this is our error handling. So right now, the way we set it up is that you could, in CLine or VS Code or whatever, it just takes you directly to the line, right? So, and it tells you which function, which is honestly horrendous in MSVC, but whatever. And yeah. All right, so what we're gonna do next is make sure to SDL clear what? Render clear, yeah. Render clear. And obviously we're gonna pass in the render, and then we're gonna check SDL render present. Render. Boom. And that's the way it is. This is very clean. But does it work? And doesn't seem that it does. And you know why? Because we forgot to show the window, the hidden window. And how to do that? Well, you gotta make sure to say check STL show window. I got bitten by these little things that I forgot so many times that I just know exactly what's the problem straight away. Okay. And boom. All right. So we have proper error handling, proper allocations, proper logging, everything working out perfectly fine. And we're pretty much ready for the actual UI stuff. Okay, lovely. So, how are we gonna do this? Where do we even start? I don't know. We'll see. We'll see. We don't need to include the side stream apparently, but yeah. All right. Where do we start? Template C. So the plan is we're not gonna have like our own widget tree and like we have to synchronize it with yoga and all that crap. Again, just like we've done with making SDL the source of truth, here for the layout and the widget tree and all that crap, we're gonna make yoga library the source of truth instead of making all these abstract interfaces. And oh my god, what if we want to use some other library other than SDL to make windows? What if we want to use this other render? What if we want to use this other layout library? And oh my god, we gotta hide this crap because we are a library. No, I'm not gonna do none of that bull crap. I'm gonna use the libraries for what they're made for, and just make it less painful to work with them. Just provide the glue code. So yeah. So how are we gonna do this? Well, honestly, I think the best way to do it is to just go ahead and do it right here in the demo. Then once we have some code ready, we could give it to the AI, and the AI could basically like make a little abstraction helper. So yeah, so this is how you do it. First of all, you're gonna need yoga, Facebook yoga. I didn't know they had like their own namespace. Interesting. No, we just need YG config. So we need a YG config ref. So this is their config. And then we gotta need a YG node ref. We gotta see how this would work. It's pretty lovely actually. All right, so how would this work? Let's see. So before we show the window and after we create the window in render or whatever, we're gonna create a new config. So YG new config new, yeah. And then we could set a few things on this. So config get context. We could set the context. Okay. Which we gotta make sure to set the point scale factor, that's for sure. We could even set the logger. I don't know if I want to deal with that right now. I mean, for completeness sake, we could tackle that now, honestly. But yeah. So essentially, there is some stuff like, let's say, use web defaults. So essentially, yoga is actually kind of used for React Native, like the CSS stuff. Do you want it to like be like web or not? And you could control that through this config thing, essentially. And you could also control the set experimental feature and stuff. We don't really I don't have like a particular opinion right now about that part. So we're gonna keep it alone for now. But what we really gotta make sure to do here is set the factor, point scale factor. And for that, we're gonna grab it from the window. And so this is your config, and here what this is, pixels in point. So auto pixels in points is equal to what? It's equal to SDL get factor, right? Like a window factor, display factor, I think. Display scale, yeah. There's even display in, what the heck is that? Oh, it's old name. All right, so let's go with this one, display scale, and this will give you back the constant display scale relative to Windows pixel size. So we're gonna grab it from the window, and obviously this could fail as all the SDL functions, I believe, yeah. But this one doesn't take a boolean, it takes a float. So, but we could just say check that this, and it would work just fine. Okay, cool. Interesting, but I don't want it to be void in this case. Yeah. So we could make a little overload again, I guess. And instead of t pointer, we're just gonna go with t and g. And I guess that might work. Lovely. Next up, and there you go. But we gotta make sure one thing though, is that when we grab an event that the display scale changed or whatever, like event window display scale changed, then we gotta make sure to set the scale factor again. And boom. But since we're having a variable there, I think we gotta make sure to do this. And I almost forgot, you gotta make sure to break, or actually not break in this case. You just return, you just return SDL app continue. And perfect. And yeah, that's just a little something there. Next up, I think we're ready to create our root node. Honestly, I'm gonna call it root, not node. Let's just call it, because it's gonna be the root tree of the tree. And so you just say yg node new. And well, new with config, my bad. Because the other one is just without config. And there you go. Next up, we're gonna say yg node. So here we could set all sorts of things. But yeah, we'll leave that for us. I guess we could set that node width maybe. But I don't know, honestly. We'll see about that. But either way, other than that, we're gonna go to, where's the destructor though of the app? Oh, there you go. So you're gonna make sure to destroy some things. Like since we're using SDL main callbacks, we don't really have to SDL quit nor destroy the window. I think nor the renderer either, I believe. Yeah, SDL will clean up the window and renderer for us. So no need for that, but you should definitely clean up the config and the node. Now here for the root, for the ownership of the node tree, of the UI node tree, what we're gonna do? We can do something similar to Qt, where like you just destroy, like basically the parent owns the children essentially. So what we could do instead could just say yg free recursive, node free recursive here, and it would make sure to destroy the node and its children. And yeah, so how are we gonna do that? Free recursive root. Another thing is that in the iterate function, we're gonna check if before the rendering part, we're gonna check if the node needs or requires, like if it's dirty essentially. So if yg, I guess, is dirty, or what? If node is dirty, whether node lighter results are dirty to or its children changing. Yeah. Whoops. So if the root node is dirty, then we're going to recalculate the layout. So YG node calculate layout, then you give it the root. Honestly, it's probably better to like go recursively, I believe. Yeah, I think you're probably supposed to go recursively and like, But you know what? Fine. Let's just keep it this way. And the available width. I'm not sure if you're supposed to set an available width here, but like what I've seen so far, you just set this to undefined, I believe. Like, in fact, you know what? Let's go to the documentation of Yoga, right? So Yoga docs GitHub. Well, C++. I don't want another Yoga to to appear on my screen. And we gotta go to their website. And there you go. So we're gonna go to learn more, and boom. This is how you do it. And then this is how you calculate the layout. Sick. YG undefined. And let's just include the header it needs here. And then again, we could say undefined. Well, YG undefined. And then here we tell it, is it LTR or RTR? So if it's gonna be like from right to left or left to right. So if it's Arabic, then you gotta use, for example, RTR, right? Otherwise, you gotta use LTR. For now, maybe we could support that stuff later on, but for now, let's just go with LTR. And yeah, I think node is dirty. Then we're gonna calculate the layout. Is there anything else there for dirty? So you could check if it's dirty, get dirtied function, and mark dirty. What is this? Returns the dirtied function. What the heck is that? I don't know. Anyways. And other than that, I think when the scale changes, we might want to say YG mark as dirty root. So we could recalculate all its layouts essentially. And actually, we're gonna do a similar thing for when the window resize, right? So like case SDL event window resized, I believe. Then well, actually, we could let it just, fall through. Yeah, we could let it fall through, I think. So you mark that as dirty, and yeah. And I believe you probably need to like set the width and the height to the window size. Yeah, I think so. So like YG node set window. What is it called? Oh, style set width. And for the node here, we're gonna set it to root. And the width of this would be, well, the window size. So we're gonna go with width and height. Honestly, I'll just call it width, fine. YG node set height. Style set height. Root, comma, height. And now the real question is, what are we gonna use for the width and height? What would you, should we use like the pixel width and height, or the actual units of the renderer, or what exactly? That's the real question right now. So window size or window size in pixels? I would guess probably we need to use in pixels, to be honest. But we'll see about that later on with AI and documentation, etc. Now here, the width, comma, height. Integer width and height. And obviously this could fail. Yes, we are in SDL. So let's just check the result and yeah. But this is really like freaking me out. Available with. Should we use the available with as the like the window size, or should the root? Honestly, let me ask the AI really quickly because that's bugging me out so badly, man. Should the window width and height be set to the available width and available height that is inside calculate layout, or should it be set to the root width and height, or both, or what exactly? That's the first question. The second question is, and for the width and height, should we use SDL window width and height in pixels or in SDL units, or what? Let's see what the AI would say, just so we can get an idea. Should pass the logical window size to Yoga, not the physical size. Yoga works by calculating in points, since you already explicitly told Yoga how many pixels in. Yoga handles the internal high DPI. If you pass raw pixels into, your layout look twice as large. Okay. So yeah, we should just use the units. Fine. And I mean, honestly, it makes sense since we already have passed it up the scale factor there, so that makes sense. Other than that, you should set both, but they serve different purposes. So the set width and height on the root node, this tells Yoga exactly how large the outer canvas container boundary is. Think of it like setting the absolute bounding width and height on web pages body element. The owner, what the, owner width and owner height? No, it's available width and available height. Should pass the exact available viewport dimensions here as well to define the constraint context. Pass the explicit window logical bounds of the available size constraints. I mean, let me actually give it the proper, because he hallucinates a lot, so... Oh, actually, it is called owner width and owner height. Okay, I thought it was available width and height for whichever reason. I'm not sure why. But fine, I mean, I don't know better for now at least, so let's just follow with it. If it's not right, then it's at least probably close. But either way. So what we're gonna do here, we're gonna basically do similar thing here. Honestly, instead of doing this bullcrap like this, what we could do is we could store the width and the height of the window, really. So like, we could say, what's the window height in our stored? I think integers, right? Or isn't it? Yes, integers, okay. So we could just say integer window width, right? In the window height. So instead of having to calculate it every single time, we're just going to calculate it in the time that, what can I say, that it changes. So we don't have to, like, every single time we change that crap, right? So width and height. And what we're going to do instead at that point, yeah, why it shows up the available width and available height here now? Bro, what? I mean, yeah, there you go. What the heck? That's strange. Anyways, here's the actual... Change your mind. Not sure the ideal approach. But yeah, fine. Let's just go with it. So the available width, we're gonna go with the window width, and here the window height. And we're gonna do a similar thing for the other ones too. So I'll just remove this from here and I'm just gonna say the width and window height. In fact, no, we gotta keep it in the window resized here, right? So, but just instead of doing this, we're gonna do this and this. Now, obviously, we gotta make sure to call this in the init too. So in the init here, we could call it right after creating the window. Why not? And yeah, there you go. And we could call this again here. So YG node set width and height. And boom. Alrighty. So basically, whenever you set the width or the height or change any style, you need to make sure to mark it as dirty. But other than that, I think we're good to go. All right, so what are we gonna do next now? Yeah, I think we're good to go. But now we need some way to attach some metadata to each layout node. So instead of making my own class like widget, right, and then it would have the YG node and color, you know, like SDLF color and stuff like that, and then I have to basically keep two trees, the yoga layout tree and my own widget tree, and I have to go crazy with synchronizing those trees, making sure they're always in sync and all sorts of crap. No, we're not gonna go that way. What are we gonna do? Our widget would too simply be a regular struct. Call it widget, right? And it would contain the extra things that we need, like for example, the color that we want for this widget. Let's say, and what we're gonna do, we're gonna come here, for example, the root, which is gonna be like our background, kinda. We could say white, well, before the styles, in fact, we could say, sorry, YG node set context, and then the node here, which is gonna be our root, and the context is a pointer. Now here, we're just gonna say new widget, kind of like Qt, and new widget. And then you just set the color to whichever you want here. And there you go. Now I guess you could just set the red, green, and blue stuff here, right? So red, I don't know, let's say 1. Or you know what, let's go with blue, fine. I know, just for testing stuff. Right? And what we gotta make sure though, since we have added this, then this free recursive is no longer enough. We gotta make sure to, before we free all the nodes, we gotta free these pointers too. Unless if we use an arena allocator, then we could indeed just free the arena too. But I'm not aware of any particular good arena library. Or we could just use like a vector. I mean, let me ask the AI here really quickly, just for a little thought. Is there an arena library or std container that we could use here instead of new widget, so we can just free the arena and would free all the widget structs instead of having to traverse the tree. Let's see what AI would say. Yeah, monotonic buffer. Okay, so there is PMR in C++, which is lovely. We could use that. Cool. The perfect tool for this pattern is monotonic memory resource from the standard library. It acts exactly like memory arena. You allocate individual widgets linearly out of it. And when arena goes out of scope, or you call release, it clears all the allocated memory instantly without you having to manually traverse the layout tree or call delete. Here's how you can integrate directly into your app class layout. Update your app definition to include memory resource. And then update your app class implementation. You can establish a dedicated memory buffer block directly in your private space to power the arena, ensuring fast performance to cache and fetch. Okay, so I'm gonna take a little break and come back. Okay, I'm back. Let's go. Let's go, Mike. All right, camera on. Cool. Let's go. All right. So we were in this memory resource thing, sure. So we basically have to have an arena memory subsystem, an inline initial stack buffer of 16 kilobytes to prevent heap crashing for small UIs. So basically just create an array as a stack buffer. Ooh, okay, sure. So we don't even have to allocate for a small UI. Sick, lovely. All right, let's do that. So we have the array and then this PMR monotonic buffer resource, which is the actual arena, which is gonna contain this stack buffer. Just gonna use that stack buffer as the backing thing. And let's include my memory resource and let's include array too. And boom. Cool. Next up, we're gonna make our polymorphic allocator out of that arena allocator. And yeah, and you just call it widget. Honestly, we don't even need an arena. We could even go with like a pool allocator, or what is it called? Sorry, slab. Yeah, slab. Because we only have like widgets here, not random sizes and stuff. Otherwise, we can also use slab allocator. Is there something more specific PMR for that? Because we're only gonna be widgets here, I think. I'm just curious. Oh, there's an asynchronized pull resource. Sick. Love that. So that's even better. I mean, arena allocator is nice, but even better, a slab allocator because it's more specific. Because we know exactly our case here. Our use case is we want something that could allocate just widgets, right? And then we want at some point just free everything. But yeah, so honestly, I'm just gonna copy this up. But basically, instead of using, wait, what it used here? It used polymorphic. Wait, what? Ah, oh, it added this in synchronized pull resource actually. Gotcha. I do need to tell it to explain to me why it included all those layers. I mean, I get it. Our stack buffer is basically our actual backend storage. And this upstream arena is like why we have, for example, this polymorphic allocator. Oh, we give it the actual type, I guess. I don't know. We'll see. Anyways, so let's just put this here and boom. And no need for comments, honestly. Cool. Manually calls the structure. Nice. All right, so now how do we gonna do this? So we're gonna create a new widget like this. So instead of this, we're gonna say this. So we allocate one widget And why we say this new W? Oh, I guess maybe just set it up or... Oh, I guess maybe to call the new constructor, to call the constructor or what? It's interesting. Okay, so we call the constructor new. This is called placement new. Oh, there is actually a way to do them both using... Yeah, that's what I thought at first. That's what I was expecting, in fact. Um, so I guess we could just say this, right? Yeah, you just say new object, tell it what is the object. But wait, if polymorphic allocator is parameterized, like what if I left off this? No. On widget, why do I have to specify it again? New object. I feel like maybe you just add in that polymorphic allocator for no reason. Maybe you just use the slab pool. No? I'm not very familiar with this PMR stuff. But like there is an allocate function here though. But no, it just bytes and strange. Construct. Oh. Does that work? Weird, I don't know. How is that legal in a slab allocator? Why we need the polymorphic allocator in the first place? Oh, now I get it. Okay, so you don't create like a slab allocator for one type. It's just that basically you could use the same slab allocator to allocate multiple types. But each type, it puts it in its own kind of array or whichever. Gotcha. Oh, like I was confused at first. What the heck? Because in my mind, you're supposed to like create a slab allocator for each type. Okay, but when it is beneficial to wrap it in polymorphic allocator then? It's kind of weird. Oh. Yeah, I'm trying to figure out what's the difference. Like, when to use one over the other. But okay, never have to type. Okay. Interesting. It implicitly converts to a polymorphic allocator. The catch, however, gotcha. Okay, whichever, anyways. So this is how you do it. So you use the widget allocator to construct that thing, or actually I'm gonna use that new object way. Sure, let's just go with that way. And then you pass it in here. So W, like this. Like this is your widget essentially. And in fact, I think I'm just gonna create a little helper function here, which basically creates node or create widget, kinda. And or maybe we could even put it in the widget. I'm not sure. But anyway, let's see what's up. Basically what I'm trying to say here is that you could just do this whole thing in one step, because we're gonna do it for all of them. So you create a node, and then you create a widget for that node, and then you kind of like construct it here. But you gotta forward the constructor here. I think you basically do some like this, something like this, yeah, I believe. Ah, we're not in Rust. So I guess you kind of have like to do something like this maybe, or wait a second. I mean, we can't just grab like a widget and just use that, honestly. Not really. Or can you? Yeah, we could ask the AI actually, in fact, fine. And then we could return the node here, and yeah, should we return the node or the widget? I mean, the node is necessary for the styling and stuff, but well, actually the widget really. But what we could essentially do is have something like, so this would return for you the widget, but you could have like some sort of essentially some SCD function, which for the styling kinda. You know, let me give it to the. Can you forward the arguments to the constructor and make a callback which gives node param. And there you go. There you go. That's what I'm talking about. So you just say auto this styling callback, and then the arguments of the constructor here, and boom, and that's how it works. You link them together. You'll want to append node to a parent here as well. You'll want to append node to a parent or the new root node here as well. Okay, well, how do you do that? Wait. Oh, add child. Yeah. Yeah, add that too, though. Add parent node too. And actually, you know what? Instead of forwarding widget args, just take a struct widget and move it into heap. That's way better. There you go. That's what I'm talking about. If the parent yeah, that's perfect. That's what I'm talking about. So let's take this in here. And there you go. So we create a new yoga node. We allocate a widget for it, and we just move the widget struct. Then we set the context. So we basically link the node with the yoga node. And if there is a parent, then we insert that parent into the end of that insert child. Cool. And then we finally fire a configuration callback and you're good to go. That's what I'm talking about. Love that. So the parent node, the widget is color, and finally the styling callback. Looking perfect, man. Looking perfect. Okay, make root widget and a few other widgets for testing. All right, so create the root node, no parent, and then create the sidebar widget and create a main content looking lovely. So just gonna take this off and put it here. Well, that's interesting. We'll create widget. Yeah, I think we should probably just return widget, but the parent is looking for node. Should we just change it to return node, as it's easier to reach widget from node than node from widget? In fact, impossible without changing something. Let's see what they would say about that part. You hit the nail on the head, gives you a direct link to its data context, provides no ability to get backwards from a raw. Okay, so we just pass in the node instead of the widget. Cool, love that. All right, so sure. Now regen the widgets. A cumulative tracking parameter. What the heck? What does that even mean, bro? Did it remove something there? No. But fine, let's just take it. That's that. Other than that, let's just grab this little demo thing. Here. Create widget. And that looking good. Okay, what it changed other than that? Doesn't seem like it changed anything here. Walks down the graph tree, accumulating parent coordinates to get absolute display. What? Why? Okay, so we basically create the render node, which basically obviously we're just gonna like walk down the node recursively and render each one. And here obviously just render the node. I mean, the parent X and parent Y, it should like be included by like Yoga itself. Yeah, I think it's probably just hallucinated here. What? That looks sus, but can you research? Because what the? You know what? Let's follow with it. Let's follow with it. See if it works or not. Too simply. So we're just gonna grab this render node. There, what's up? Shadowbite, welcome to live stream. I'm not sure what you're talking about. So let's include this header, YG node layout. And basically, if not node, then we just return. Otherwise, we calculate the absolute coordinates inside the window viewport. So obviously, after you calculate the layout, you could now say get left, get top, get width, get height, etc. And here the absolute x and here we're adding this parent x and parent y for whichever reason. I'm very skeptical about that, but let's just leave it for now, just in case. And here you grab the actual widget from the context, and if widget, then we're gonna make a SDL rect, and then we set the draw color, and then we render fill rect, and then we go through all the children, and then we draw them too. Yeah, all right. And now, before present and render, and after clear, we can say render node root. And let's see. So, what's the problem? Yeah, and here I guess you could say 0, 0. We could make that defaults actually, but anyways, let's see if this works. Ooh, all right. But what if we don't take into account the parent X and the parent Y? How about that? Let's see if that's really true or not. Yeah, it doesn't. Interesting. Okay. Nice. Love that. So, and now we got an actual layout. Perfection. Whoops. Only leaf nodes with custom measure function that manually mark themselves as dirty. Interesting. But let's just remove the marking stuff for now, I guess.
And let's just always calculate the layout for now. So we don't have to deal with the layout dirtiness tracking right now. And boom. That works. Lovely. Okay. Okay. Nice. Okay, now let's bring back that dirtiness stuff and let's try to fix it hopefully. And obviously I'm not gonna fix it myself. Let's see how the AI would do it, and we also need to check the documentation too. When I resize, I get this. Comported box MPG, welcome to livestream. In yoga, you're not allowed to call mark dirty on any node that has children. Yoga keeps track of its own dirty flag state automatically whenever you change style. Oh, it already does that. Oh, okay. So already actually keeps track of that. Nice. So let's remove that mark dirty thing because apparently it does that already for us. That's lovely. And I'm not sure if we are supposed to keep that YG node is dirty there or not. Let's see. Actually works. Though on the other hand, I did find something else when I was looking into the calculate layout function. There was this. It has new layout. So instead of this, we could also use that. I'm not sure what's the difference, to be honest. We gotta ask the AI. Rouge. So there's a new layout, then we calculate the layout. The other thing that I'm not sure about is that, yeah, that seems great. What? Oh, okay, so no, that's not how it works apparently. Okay, fine. Oh, we only render if... Bro. But no. You still gotta like present, I guess, and clear every frame, no? Yeah, so just gotta do it. All right, so where are we gonna move next now? That's the real question, I guess. And yeah, it just works. So you just say create widget, you give it the parent widget, this our custom widget that contains some stuff like color. And here you set the styling using, obviously this could be way better if we just created the builder pattern for this, but that comes later. I don't want to bloat the API right now. Right now I'm just removing the glue part. I'm not really working on making this like cool looking or whatever. Just handling the plumbing. Yeah. So like for example, here in the create widget, instead of, you have to create a yoga node and then you have to use an allocator and create your widget objects, and then, you set the context, you link them together, and then, you know, if the parent, then insert the child, and then, instead of doing this bull crap, right? And the same thing with the render node, for example, here or whatever. Yeah, you just do it, right? Same thing, obviously, also with the inch CodeTaco entry that handles the SDL app callbacks for you, and also the allocations and all that crap, right? But yeah, other than that, this is amazing. This is lovely. So maybe next up, maybe we should handle text, I think. Yeah, maybe. Here's the correct standard way to build, blah, blah, blah. Okay. Is there a way in SDL to like pull to only iterate? I mean, there's obviously that, but I don't know. Like setting, just to clear. Yeah, I believe there should be something for callbacks. Not really that. Let me just reread the documentation about the callbacks, because there could be something interesting there. There's also this non-standard startup. Nah, I don't think there's anything interesting there. Maybe I should check iterate instead. Where's the iterate function? Hold on. There's, for example, this main callback rate, which is cool. So this basically allows you to change the how much times the iterate function would run. But is there a way we could tell it so that it does that every hmm. But yeah, maybe they should read these off camera anyways. All right, whichever. Where are we gonna go right now? Yeah, here. So what it did. Okay, so it's telling us just to use the event only for rendering. Um, really? But I mean, the iterate would still run every frame, which sucks. Nah, I don't think that's good. I don't think that's good. There's definitely some way to like do it using main callbacks. I just don't know how. Maybe we could like look into the document, like sorry, the source code. Uh, you know what? Let's try something interesting here. Just a little adventure. Since we have built SDL from source, we could do something pretty cool, I guess. Like, who's calling this? Oh, it doesn't tell me who's calling app iterate? Really? The call stack? Where the heck is the call stack? Why it doesn't give me the whole call stack? That's weird. I was expecting it to give me the whole call stack. Does SDL have their own thread or what the heck? No. Interesting. Let me ask the AI actually. Hello, Sion Magger. Welcome to livestream. I'm basically making a UI library. Using SDL3, and here's what we got so far, and yoga. So basically the meta library, layout meta library. So this is what we got so far. We're gonna work on text soon, but I'm just looking into something. Why I can't see SDL code that is calling my watch, my callback. Although I compiled SDL from source. I mean, it's not a big deal, at least for now, but it would be nice if there was a way. How much money do you earn from coding? That's a... I wouldn't answer that question. Even though we compiled SDL3 from source, your debugger LDB cannot see or step into the SDL internal functions below. For one of three reasons. SDL3 was built in release mode instead of debug. Wait, am I in release mode? Actually, am I in debug? What the heck? Maybe it's because I have made this third party. Well, did I? What if I in market? Would that help? How to learn all things. Just do and you learn. um, okay, so let's try again. Let's see if that fixes the callback thing, the stack. Wait, no, go back to, so here. Yeah, no, it still doesn't really provide me with that. Interesting. I don't know why. Wait, maybe it does. Hold on. Actually, here we go. Was that in there before but I didn't notice or what? No, it wasn't. How about now? So if we go to app iterate, use Claude AI. Claude AI is not free. There you go. Okay, so apparently when you mark the third party as libraries, it doesn't actually show you the call stack of the library. That's stupid. Fine, whatever. Alright, so this is the actual call stack. So you got the main function here inside of SDL main impl.h, which calls SDL run app. Giving it this SDL main with argc0. What? Okay. Either way, so this is the main function here apparently. Next up, you got SDL run app, which goes through the DLL obviously. Like there's a free way you can have the Claude code from GitHub. Huh, really? I don't know about that. And honestly, wait. Ooh, CLine is not responding. Strange. Okay, so we come here into the run app, Win32 specific run app, which does most of the SDL main work. So I think this is where the actual code that we're want, maybe? Or isn't it? So here's the callback rate increment stuff. Here where it checks the callback rate. Let's go. Nice. So this is the code I was looking for. And what it does, so SDL in its main callback, so it calls that for whatever reason. And if I've continued, then we add hint callback rate, main callback rate change. Get 6 nanoseconds, generate iterate main callbacks. There we go. This can be made more complicated with side 2. Optionally hand off callback responsibility to the video subsystem. For example, Wayland has a protocol to drive an animation loop. Maybe we hand off to them here if when the video subsystem becomes initialized. Try to run at whichever rate the hint requested. This makes the so currently it's 0, so it just does this. But otherwise, yeah, apparently it just uses this delay precise function to sleep otherwise. But yeah, there's nothing about input, throttling on input. But we could do it ourselves. We could just do it ourselves, yeah. And we could even like just use this delay precise, or actually we could use that wait for event thing. Yeah. All right, sure. So in the iterate function, what we could do is if Git has new layout, then wait. Da, da, da. Yeah, so if we have a new layout, then I guess we do this. We draw again. And what this needs, the node, which is root in our case. Otherwise, we just wait. So wait for the next event. How do we do that? Well, we just say SDL wait event, I believe. Yeah. And just passing null PTR here, I think. So what if we done that? And let's just print something, I don't know. Or well, stdc out. Hey. It seems like they always have new layouts. That's weird. Yeah, I'm not sure how that really works, to be honest. But we, instead of doing this, we could just remove this for now, at least until I figure out how that really is supposed to work. But for now, we're fine. Maybe we could just say wait event like that. Right now, it will only render. Oh, but the resize sucks now. It can't resize. And yeah, it just crashed. Yeah, I don't know. I don't know. For now, we're just gonna render every frame and call it a day. No weird crap there. Very simple. No mark dirty or whichever. We're not gonna handle that right now. So yeah, that's basically how it works. So that's lovely. All right, so now let's move to the next thing, which is the actual text. Or honestly, we could even ask the AI and see what's its opinion on where we're gonna move next. Okay, which route you suggest next we take this? We could start by actually creating the library out of this already, but honestly, I want some more things like text, for example, and images before I start abstracting this out. Because, yeah. And let's go. Maybe I should just start a new chat already. Yeah, let's start a new chat. And let's even just refresh this. Viewport calling damage tracking. Massive grid or list with hundreds. Check if a node's absolute bounds actually intersects the window canvas before issuing a draw call. I mean, who knows? Maybe SDL is already doing that stuff. And honestly, I'm just gonna ignore this dirty stuff for now and damage tracking for now. It's just an optimization, really. You have a data-oriented widget context, but UI requires interactive context like text wrapping and measuring text boundaries dynamically, so Yuga knows how large container node should be. Hook into Yuga's measure function, register, so you can query your text engine to calculate accurate inline node heights. You map raw mouse events, mouse motion. Yeah, I think we should definitely add text next, so we could have something going on. Look closely at your current cleanup loop. Component cleansing and cleanup. Memory architecture fixes. Tears down the Yoga layout handles, but it does not call or free the memory. So either hit testing or text next. Let's go with hit testing. Okay, sure. What is the UI for? EclipseCon. Well, you could it's basically a UI kind of framework. Not exactly for it's the UI library. So basically you include this library into your SDL application essentially, and then you're going to be able to include UI that is using SDL render in your application essentially. And so it's going to be something, I mean, we haven't really abstracted this into the library just yet, but it's going to be something similar to this. You just include, let's say, Kodotaku utils, and then at the end of the file include Kodotaku entry, which kind of like use the callback SDL callbacks for you and stuff for C++. And it also includes wires up for you some SDL allocation functions, etc. You know, just some plumbing. And then here you just include a log redirector, which redirects your STDC out and STDC RR, like all the log streams to SDL. And yeah, you just create some few things. Now, obviously, this would actually go probably into an abstraction that we're going to include in the library, but not yet. But so far, what we got, you could basically build the widgets like this so far. So you just create widget, you give it the parent of the widget, and then currently we only have color. And then you got the styling callback, which you can call the yoga functions to set the styles using a flexbox kind of thing. And then you set the width, set the height, set the padding and stuff. And then boom, you just get a UI. And just like renders the UI for you. Now we still have the actual code inside of our demo, but we're gonna move this soon. Once we have enough context, we're gonna move this into the library. Yeah, see, that's really cool. Yeah. So right now, I think I'm either gonna implement hit testing or text. So far, I think we maybe could implement hit testing. We'll see about that. So let's go with hit test. So I never actually implemented hit testing yet. So let's just assist with the AI here. So adding tests require calculation forward metrics, setting up texture caches, and hooking up yogas, measurement callbacks, which a lot of plumbing. Hit testing can be done with your existing layout tree and geometric nodes immediately. Turns out, you know what? Honestly, okay. Here's how you can implement a recursive hit test routine that identifies exactly which widget the user clicked. Update your event handler and tree traversal. To find the clicked widget, we need to search the tree from the top down because children rendered last appear on top of their siblings. Okay, we should traverse children backward from last to first to correctly respect the visual track in order. Add this method to your app class. Hit test. You give it a node, you give it a parent X and Y, and then the mouse X and Y. And then it checks if not a node, and then calculates absolute bounds for this node. And then it checks if it's inside. It could have used just SDL rect in thing, but yeah, fine. If not inside, then we're gonna return null PTR. Otherwise, we're gonna search the children in reverse order. How are we gonna do that? -1 I agree. No, that's just like children. Return hit. Return the deeply nested child if hit. Nah, I don't think that works. I mean, it should work for the usual case, but not the actual. But we'll see. We'll see. Anyways. Actually, let me tell it that. Let me tell it that and see what it's gonna say. Well, you're iterating only the immediate children in reverse, not the actual tree of descendants in reverse. Because I'm not sure if it's aware of that or no. Or maybe I'm just not catching something here. Oh, wait. Oh, maybe it actually does. My bad. No, I think it's probably doing that already. Because I didn't actually notice this recursive call. Yeah. You know what? Fine. Let's just try this out and see if it works. I mean, it seems good, actually. I just was not noticing that. All right. Node parent x parent y mouse x max mouse y. And we're gonna add the event, hook up the SDL event here. Yeah, just that. Let's add it here. Let's add it to the end. Or honestly, since it's more frequent, honestly, you know what? Add it to the start. Really. I don't think it even makes like any difference, but anyways. So if event bun is equal to SDL bun left. Yeah, that seems good. All right, let's try this out. Would this work? Oh. Okay. But isn't it supposed to be on hover, not button down? Well, actually, it works fine. Inside reverse loop. Honestly, I'm not sure. Awesome. Seeing the node change color and click means your geometric layout is officially an interactive tree. It's text rendering. Okay. To make text work properly with the layout, like you can just draw strings and random. All right, let's just hook up text already at this point. Fine. Let's just do that. So how are we gonna do that? Well, we're gonna go to third party SDLTTF and we're gonna go to examples and I think show font. Okay, and we have a little example here to test text render feature of that. So SDLTTF have changed a lot in SDL3 and it's actually way more efficient than before because it's actually using the GPU to like create a so instead of like creating a new glyph and like uploading it to the GPU every frame, etc. What it does is kind of like have an atlas of lazily loaded font glyphs, right? Glyphs you could say kind of like characters essentially, although yeah, the glyph is basically the more technical correct word for it. But anyways, and yeah, it's just essentially much more optimized. Anyways, let's go to the next. What's going on here? Let's see. So first of all, I think we gotta create like this text engine. Isn't that the case or what? No. No. There's this TTF text and TTF font. And yeah, that's the only things I see there. Either way. So this is how you draw. You just give it a TTF text to draw. and the X and the Y, and then a surface where to draw, I guess. How would you explain this DL to a 5-year-old? I wouldn't. So it's basically, instead of having Windows or Linux or Mac OS, you're programming for SDL. That's your operating system. So yeah. Render texture. Render scene message, no. Update Windows Surface. Apparently, I think they're using software rendering here, or what the heck? Yeah. Interesting. I don't know. Weird. Fine. And this is how you grab the text position. Okay, but like where we are right now, that's not our business right now. Where we are like initializing this stuff. This looks strange. Yeah, this is weird. Oh yeah, they're creating a software render apparently. Interesting. This is what we need. We need to create a render text engine. Okay, so here apparently they're basically configuring both. They're configuring like software rendering and GPU rendering. But in our case, we only need GPU rendering, so I guess we gotta call this guy. I do remember you have to like do SDL like TTF init or something. Isn't that the case? Or is that got removed? I mean, good question. No, there is. There you go. You initialize the TTF library. Yep, okay. So after you create the GPU thing or whatever, what was that? Oh my god. Text engine was that? Oh, render a text engine. So this is, okay, so how they're using this engine exactly? Show which font files we're looking at. And then you use the engine to create some text and you give it a font and then a string. Okay, and then how you create a font then? You use CTF open font. All right, maybe I know what's up. All right, let's see. Let's just see. So after SDL init, I guess we could say TTF init. No parameters. Okay. And then what? We're gonna try to load some font. And I believe I already installed the inter font, which we could use here. Let's just go with the static one. You could go with whichever you want. Let's go with ADP. Why not? Okay, back. All right, so we're gonna grab the regular here. Where is the regular? Regular. Okay, let's grab this ADP regular, and we're gonna actually create a little assets folder or something, or about that. Sure. Let's create an assets. Well, honestly, we should do it for the examples, but for now, let's just do it here. Why not? So let's grab assets and let's put it here. Yeah. So we're gonna add it to a fonts folder. We could potentially include or embed some font maybe as a header. Maybe we could find some tool that could do that, but either way, for now, fine. So ttf init sick. So what we're gonna do next is, in fact, maybe before even we create a window in the renderer, yes, we could try to load some fonts. So font is equal to ttf. So let's see what we got here. Open font. Okay, so we could either go with open font, which you basically give us some file name and some pt size, how big it is, or you could use this font IO if you want to load it for memory or something. In our case, we just want to load it from a file, and we're just gonna say here, first of all, we're gonna grab the base path of SDL. So SDL get base path. And then what you're gonna do here is std format. Well, let's construct the font path. It's basically std format, I believe, and then base path, comma font path, which is in our case it's assets slash fonts slash whatever this is. Copy the name, and there you go. Let's just try to see what kind of font path it's trying to load here really quickly to make sure it's correct. There you go, and here's the path. And well, it's inside of build debug, but like if we change it here for now at least, could change this working directory to there. Oh yeah, very helpful. Well, in fact, it's easy. We could just go to here, 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 and there you go. Let's just set it to there for now. The working directory essentially. And whoops, wait. Let's see if the path is correct now. Wait, what? It didn't actually change. What? Oh, so it doesn't really care about your working directory, huh? Interesting. Only so base path is basically where the executable is inside of, no matter where you're running it from. Interesting. So what we're gonna do then is to copy that assets folder using CMake. I'm gonna tell it that. Copy the assets folder in root for the demo. And let's just copy this. All right, let's just copy this. Oh, it's gonna do both in one. Okay. And let's just try to right now open that font, I guess. And what it's doing. Okay, maybe right now we could check the build and debug, and there you go. We have copied the assets. Sick. Now we could open the font. So how are we gonna do that? We're gonna say auto ttf, well, font, sorry, is equal to ttf open font. Now obviously this could return null, or yeah. Yeah, you use a steelgit error. So we could just say check. And here I believe the font path, and then here how big you want it to be. I don't know, let's say maybe 16 or whatever. I don't know. And then here the font path, we gotta go with C string. And yeah, so let's make sure at least it's loading this font with no problems. Come on. Perfect. So now what we're gonna do, we're gonna need to create, I guess, also a like after creating the render though, where is dash? There you go. So after doing that, and even in fact, yeah, after updating that stuff, etc. Let's do it here, fine. And or actually, fine, let's do it here. And for that, what we're gonna do is TTF engine, I believe, or something. I don't know. Let's see. Create font. Render. Yeah, render text engine. They just give it the render. That's it. And obviously, we gotta actually sort, I guess, all of those or something. In fact, I believe I've seen like some sort of TTF list or something. Hold on. I don't remember what they call it. It was something in Raylib too. Well, not SDL2, SDL3 obviously. Yeah, I'm not sure where I've seen that one, but either way, fine. There you go, quick reference. So this is what I was talking about. Okay. I think it probably have another name, but anyways, so yeah, let's see. So how do you render text? There you go. You give it a font. Oh, but it like this one renders into a surface. No, where's the renderer stuff? Draw render text. Okay. What? Does it like use the current render or what? That's weird. You know what I'm gonna do? I'm gonna copy this thing. I wonder if it's gonna be enough to fit in all of this. Yeah, I guess so. So you just add that TTF text there into the widget. And then you create this measure text node, and then initialize the text engine and the font. create render text engine. And yeah, that's all actually. Just open the font, you create the render text engine. Then you could say TTF create text using the engine and the font. All right, so that's how it works. Gotcha. And then you render the texture into the traversal. Okay, cool. So it's not that hard, I guess. So here we're gonna have like the TTF render. What? Oh, it's called text engine, okay. And then you also have a font. Where I'm gonna put that, let's put it here actually. TTF font. Oh, whoops. And finally, in the widget itself, it's gonna hold some TTF text. And there you go. So now we're gonna say that this is font. Honestly, let's do this font loading after the create window render, etc. Fine. And this guy, we're gonna say engine, text engine is equal to that. Fine, and let's just load the assets here. Anyways, font, that, cool. Now what we're gonna do, yeah, let's just copy honestly this part, measure text node. Where are we gonna put it? It's a static function, huh? So let's see what it does here. Anyway, so if widget and widget text, if Hugo tells us the target maximum layout width, pass it down to wrap the text. If width mode not equal to measure mode in the fine, TTF set text wrap width. All right. But this could fail though. So you gotta make sure to say check. And if no wrapping, then we just to wrap. Wait, 0 is for wrapping on new line characters though. Either way, fine. Let's just keep it for now. We'll see how that works. And text W, text H. TTF get text size. So here you get the text size, and obviously, well, actually we just say if that, then we return the YG size. We return the text W, text H. Otherwise, we return 0, 0. But here we have a little problem because a function YG node. Why the heck it's trying to set the context here, bro? That's stupid. You're just supposed to grab the context. I don't know what the heck it was trying to do there. That's weird. Okay, what we do next? We initialize blah blah blah. Then we could create a text widget. Oh, parent content. Styling callback. And for that, you just say TTF create text. And you set the color. I mean, I see what's happening there. Fine, let's just use it. I mean, just a little shortcut for now. But we gotta think about how we're gonna like integrate this exactly. Whoops, wait a second. Let's actually call this that. So text engine. And yeah. Now let's go back here or whatever. And let's say text engine like this. And then we got like create text widget. Where's that? What? Oh, that's not the way I want it to be like though. Actually, just say widget, bro. No, that doesn't work that way. Or widget new, or anyways. What the heck? That's weird. Fine. All right, next up, what we're gonna do is render text during the tree traversal. So if the widget text, then we do this. If we widget text, where we're rendering the node here. After we render the rectangle, then if there is some text, oh, it's not giving us the, I see. You could set the text position. Absolute X absolute, that's stupid. Anyways, draw render text. All right. Well, whichever. Don't forget cleanup. Sure. Where's the destructor though? What? There you go. So TTF close font, TTF destroy. That looks correct. Next up, what we got? Yeah, I think we're good now. Right now, we're just gonna add some text nodes. But before we do that, honestly, how about it gives some more control to the text? Update the render node to pull properties from the specific widget context instead of using static values. You know what? Never mind. Let me just tell it to generate he makes some some new demo using these widgets. So we can make sure first of all that this works, then we could move on to the next, which is alignments, etc. And let's just copy this little demo here that it got. And let's see if that works. So in the application here, we got this. So we're just gonna say, crap. It's using create widget and create text widget. Yeah, let's remove that. Let's actually tell it. We didn't, I don't think we set to the, or did we? Oh, we're setting it here. Okay. Gotcha. Gotcha. Anyways, so we're gonna put that in here. Hold on, where's that? Okay, here. Let's see if the text works. And whoops. I mean, we got some text into the screen, but it doesn't look that great. First of all, it's black. And second of all, it's not really wrapping over. As you can see, it just puts it in the top left. You gotta add alignments and stuff. Right after creating renderer. Okay, let's see where we're creating the renderer. There you go. Would that fix the black part, first of all? Yes, it does. Sick. Yeah, we definitely got to think on how we're gonna like deal with multiple text like widgets types like text, but right now we're just kind of trying to get something working. That's it. But I kind of like the way it's going to right now. Okay, why it doesn't respect the window width and height at all? Yeah, I kind of like that. So the text node should basically be nothing, it's just the text without a color or anything of that, I guess. Why the... No, I mean, wait a second. In the window resize, we set the width and height. Then we try. Okay, what if we say YG and define? Would that fix that part? By any chance? Did it also make sure to update the root with that? I can't tell. But let's just leave as it was. But yeah, I think maybe have notch. I mean, we do have root window width and window height. That's strange. Create wrap measuring, create widget, and cancel button. Set width percent. It is setting the width and height here, so that's strange. Why resizing the window doesn't respect resizing the window anymore? Bro, what? All right. Well, no, that's actually no, that's well, I guess I'll probably just have to read through this by myself. At least the text part. and the examples, etc., and figured it out. I mean, let's try that out. Let's give it a chance. I don't know if that's really the problem here. And I mean, I don't know. We'll see about that. Fine. I'm just gonna get it back to what it was before. All right, so I think for now, I'm just gonna first of all like commit all of this. And we're gonna create a git ignore, remove the .id and probably the build folder too. So where's git ignore? Let's create a .git ignore here. The build, and what's next? The idea. Okay. And okay, cool. Now let's add this guy, and let's just okay, so I'm gonna be like publishing this after this we end the live stream. So yeah, that was it guys for this stream, and tomorrow hopefully we're gonna like abstract this away into a library, into our library, and yeah, and hopefully fix the TTF stuff too. But other than that, that's it for this video. Thank you all for watching, and see you in the next one. Bye everyone.